everyone, I am Lorna Williams, a trained mathematics teacher. Welcome back to my channel, Bloom Your Math and A is your grade. This is a class where I teach you mathematical concepts and then provide you with worked past paper questions in our Take 5 series. Today's lesson is on solving simultaneous equation by a matrix method. Let's get started. Okay, so we're on to question 5, and this time we're going to be using a matrix method to solve simultaneous equation. Please be reminded that there are about 4 different methods of solving simultaneous equation. We have the elimination method, the substitution method, the graphical method, and the matrix method at the CSEC level. So we are on to the matrix method, but be careful, if CSEC asks you to use the matrix method, you will get 0 for trying if you use other method. So stick to the method that they ask you to use, okay? So again, I'm depending on you to help me to read the question. So shout it out loudly. Using a I missed out the word matrix. But this is very important. You can't use any other method but matrix method. So using a matrix method, solve the pair of simultaneous equation. And just a quick little reminder that simultaneous equation just simply means that you must have 2 equations, and our aim is to find the value of the variables x and y in this case. It could be any letters, any 2 letters, but in this case it's x and y. Let me just give a simple, quickly example, because I normally like to teach and then go back a little bit just to refresh your minds as to what we're talking about, so it doesn't look too far-fetched. So if I have x plus y equals 10, and x minus y equals 8. Those are what? 2 equations. We call it equation 1, equation 2. Now, all I'm asking you to do is to guess this time. I'm not telling you any method. Just guess. Which 2 numbers can we add to get 10? And which 2 numbers can we subtract to get 8? Those 2 same numbers. So my aim is to find what x is, what's the value of x, and what's the value of y that will satisfy both equations. It is true for both equations, not just for one. Did you say 7 and 3? Alright. 7 plus 3 equals 10. Yeah, that's true. But 7 minus 3 equals 8? No. That's not true. So that we don't spend too long on this, I'm going to give you the answer. But I know you get the answer long ago, It's 9, x is 9, and y is 1. And how can we prove the answer is correct? By just substituting. So 9, x is 9, 9 plus 1 is 10, and 9 minus 1 is 8. So x equals 9 and y equals 1 is true for both equations. So that's what simultaneous equation really means. So there are 4 methods that we can use to solve it, and we are actually now using the matrix method in this particular question. Okay, so we need 2 equations, a second equation if we have 2 different variables. If I only have 1, it can take on 7 and 3, 10, 6 plus 4, 10, 9 plus 1, 10, 10 plus 0, 10. But if you get a second one, then you would need to find the value that will satisfy not just 1, but 2. So that's what we're aiming for. Alright, step 1 is to first separate the numbers from the letters. So we call them coefficients. A big word, but all it means is a number before the variable. So the number, so that's negative 1, and then x is 1 here, and y is 3 there. And then we're going to be multiplying it by the letters that we are required to find, the unknown. Remember over there we were talking about finding the value of x and y? That's basically here what we're trying to do, find the values of x and y. Alright? Equal sign on the equal sign, and then the constant over here is 0 and 7. You got that? Alright. Now, if you watch my previous videos, you will learn the reason why I derived the formula to find the values of x and y. And that is a to the minus 1 times b. And if you forget how this formula was derived, then I'll put the link in the description box below. But that is a formula. And once you get that, you're good to go, you know. Problem has begun. What a to the minus 1 means, do you remember we just did it a while ago? Yeah, it is the inverse. And do you remember the formula for the inverse? Yeah. Once you get that, you simply multiply it by b. But now, where we get the a and the b and all sorts of things from, we label the first matrix, use a capital letter. So A is the first matrix, a 2 by 2 matrix, 2 rows and 2 columns. The X, or we could use the XY in this case, doesn't matter which one you want to use, the capital X or the XY column, is equal to B. But if on C, if in you're doing your CSEC and you see CX equals D, don't let that frighten you. It means the same thing. They're labeling the first 2 by 2 matrix here, the 2 by 2 matrix, the C, the X is the XY variables, and the D is a constant. 1 over the determinant times the adjoint of A. So now we have a to the minus 1 equals 1. What's the formula for finding the determinant? It's AD minus BC. That's, when we work that out, we'll get the value of the determinant. And there are 2 steps to find the adjoint. So the matrix A over here is 2, 1, negative 1, and 3. So there are 2 steps. Don't forget, not 3 steps or 4 steps or 1 step. Once you hear the word adjoint, think 2 steps. 2 steps to find the adjoint. So basically, that's the main diagonal. Do you remember what we did with those 2 numbers? We switched them around. Alright. So we just switch places with them. And then do you remember what we did with the other 2? The negative 1 and the 1? We just simply change the sign. So negative 1 becomes a positive 1, and positive 1 becomes a negative 1. And basically we're going to now try to simplify that to find the inverse. Because the formula says find the inverse first, and then multiply it by b. b is a constant that comes after the equal sign. Okay? So a to the minus 1 over AD minus BC, and again we need to label. But by now you don't have to label it, but because I'm for teaching purposes, let me do so. A is the top left, just for a quick reminder. D bottom right. B, and this is C. So I use a capital letter to name this matrix. capital letters to name these matrices. Singular matrix, plural, matrices. Alright, so A is 2, D is 3, minus B is negative 1, and C is 1. And I'm going to be multiplying it by the adjoint of matrix A, which is 3, negative 1, 1, 2. So A to the minus 1 is 1 over 3 twos, 6, minus negative 1 times 1 is negative 1, times 3, negative 1, 1, 2. A to the minus 1, 6 plus 1, times 3, negative 1, 1, 2. So you notice that each time we are simplifying it to aim at the answer. 1 over 6 plus 1 is 1 over 7 times 3, negative 1, 1, 2. And again, you can leave the answer like that, or you can get it to fractions. So, and this resembles the previous question. So we should go a little bit faster. 1 over 7 times 3, 1 over 7 times 1, if it's not even the same. 1 over 7 times negative 1, 1 over 7 times 2. Over 7 times 3 is 3 sevenths. Remember to bring this to a fraction, multiply numerator by numerator. I'm going to skip all that step. 1 7, negative 1 7, and 2 7. So we have found the inverse of A to the minus 1. And so we are going to now multiply using the formula. So using the formula, xy equals A to the minus 1 times B, which is what we noted earlier. And I'm going to highlight it in red. If you forget anything, please don't forget the formula. Okay? So we're going to have, we're trying to find the value of x and the value of y. We are one step down where we found the inverse, which is this fraction. So I'm going to now rewrite it. 3 over 7, negative 1 over 7, 1 over 7, and 2 over 7. And we're going to be multiplying it by b, which is anything that comes after that column matrix that comes after the equal sign. You get that? So the 0 7 is b. It could have been any other letter, you know, but in this case I named it b. Okay? So that b is a column matrix with 0 and 7. And again, we're going to be multiplying now these two, and there is a way to test matrices. Again, watch all my videos on matrices because it would take me quite a lot. First, you'll have to test if the two of them can be multiplied, and I've done that extensively using my overhead projector, typed notes. So you can't say that you can't make up my handwriting. No excuse. I know some of you, you know. See, all right. I'm not going to say anything more because guess what? I really want you to get the math. How badly do you want to pass the math? Follow me. Alright? So we are going to now use a red marker to label row 1. Because the row goes horizontally. Row 2. And in the second matrix, we only have one column. So here we go now. We're going to be setting up, this is a 2 by 2 matrix and this is a 2 by 1. So they can be multiplied, and then the answer size is a 2 by 1, meaning 2 rows and 1 column. So I'm going to erase this so that it doesn't look too jumbled. Just this little part here. And I'm going to extend the line. So we have enough space to write. And then I'm going to be multiplying first with first, second with second. So basically this is, okay, so this is row 1, column 1, and this is row 2, column 1. It's only one column. So that's how we are going to work to get our answer. Row 1, first element is 3 over 7 in the row. First element in the column is 0. Plus the second element in the row is 1, 7 times the second element in the column is 7. Finish with row 1. We're now on to row 2. First element in row 2 is negative 1, 7 times the first element in column 1 is 0 plus the second element in row 2 is 2, 7 times the second element is 7. Okay? And I put in my brackets there because you know you have to multiply before you add. So we don't want a bunch of numbers spreading all over the place, right? So x, y now, and help me work this. 0 times any number is 0. Can anything be cancelled here? 7. 7 into 7, let me use my red marker to cancel. 7 into 7 goes 1 time. Good. Bottom row now. 0 times any number is 0. Plus 7 into 7 goes 1 time. So we're left with 0 plus 2. So our final answer is 0 plus 1 is 1 and 0 plus 2 is 2. Meaning, therefore, x is equal to 1 and y equals 2. And so we will have solved our simultaneous equation. And then what you tell me how I know if my answer is right if I come out of the exam and know that I will be getting full marks? Just like 9 plus 1 was 10, and we proved that, and we know it's true. And 9 minus 1 is 8, because we made a substitution and it satisfied both, then those answers must satisfy both. And I'm going to spend that extra little minute to show you that our answer is correct. And then we're finished. And you can go and eat your curry goat. Alright, so here we go. I'm just quickly going to show you in this spot here that we have 2x minus y equals 0. But we found the value of x to be 1. And we found the value of y to be 2. So 2 times 1 is 2. And 2 minus 2 gives me 0. So our answer is correct. We made the substitution and it is correct. Most of the things in mathematics deals with substitution, you know. So if you can substitute, you're good to go. And don't just test for one, test for one, because it must satisfy not just one, but both. So we have x plus 3y equals 7, and we know we found the value of x to be 1. We found the value of y to be 2, but we know 3y means 3 multiplied by y, which y takes on the value 2. We're not even putting equals 7 yet, because we don't work it out. So now 1 plus 3 2s, 6. And 6 plus 1 is equal to 7. And that's true. And therefore, our answers are correct. That's it for question 5. That's it from Bloomer Math. Affirm today, I can achieve excellence in mathematics. Don't forget to like, share, and subscribe. You may hit that notification bell to alert you when I get new videos. Bloomer Math signing off. Bye.